Hello, Flat Earth researchers, debaters and debunkers. It's a lovely, clear night tonight here in Portishead in the UK, southwest England, and the moon has recently come up in the east. And I wanted to point out the difference in what we see when we look at the moon and the way it's positioned compared to how we see it in Thailand near the equator. I should just zoom in on it first, just so you can see that looking kind of straight up at it, you can see that the shadow is on the top right. Yeah. Sorry if it's not very clear, but you can see that. Yeah. And so we have what you might want to refer to as the rabbit ears at the bottom, pointing to the bottom right. Yeah. So we've got this kind of upside down rabbit illusion on the moon. So that's the way it's appearing to us from north of the equator in the UK. But in Thailand, near the equator, I see that shadow on the top. So if I'm going to represent the moon how it's seen in Phuket, I have to do this. And if we zoom in on it now, we'll see the shadow and the rest of the moon appears how I would see it in Phuket near the equator, looking straight up without tilting the camera. But in this case, I've had to tilt the camera like this in order to see the moon in the same way that it appears if we're on the equator. Yeah? So what does that mean as far as trying to illustrate the Earth and the moon's relationship? In some ways, you could say that it means if I'm on the equator, then I'm at this kind of angle compared to the angle I see it from here. But that would kind of dictate some kind of concave illustration. I'm not using the word model here because there is confusion when it comes to the term model, which is just a bunch of predictive events or observations, or more like physical events that we can see and then have explanations for. Explanations are not what a model is, and nor is any kind of illustration. That's not a model. The model is that the moon at this point in the month, just after full moon, is coming up a long time after the sun has set. So anyway, back to this arrangement here, just looking straight up at the moon. So, that's the thing about observations. We can observe the moon in different places, and we can recreate how the moon looks in different locations, but that's not a physical measurement. There is no way, for example, to measure that we are suddenly tilted this way if we're on the equator compared to how we see it north of the equator here. And it certainly doesn't dictate that we're on a spherical Earth if we have to do this in order to see the moon in the same way as we do at the equator. Again, I've got to emphasize that this is just an observation, and we change our position or our point of view, our perspective, if you like, to recreate an observation that we would make somewhere else. But another way we can look at it is that if I'm facing east-ish now because the moon has recently risen, then if I'm to see it in this way from a country in the east of here, as it were, then we can we can't really do it, but we could perceive that, of course, the moon is going to take this path overhead. That's not like the direct path overhead that it would take. It would come up and over at the equator, but from here it's going to go around like that and go to where the sun set on the opposite side over there, and it will kind of make its way down, but you won't be able to see it because there's a hill in the way. Yeah, but really the point of this is to demonstrate the difference in an observation of something in the sky and how we can interpret that in a variety of ways. As I said, we could then somehow perceive that we're on the inside of a sphere or some kind of concave dish-like arrangement. Not when I say concave, I don't mean a sphere. I just mean that, but again, this is not something that's physically measurable, and this is not something that you can assume just from an observation. You can assume any number of different scenarios to have us looking at the moon like this here north of the equator, or to be at this angle if we are near the equator. We can come up with any number of interpretations, but the model doesn't really change. The times at which this happens, or the space of time between the sunrise and the sunset and the moonrise and the moonset. In this particular case, the moon is coming up at night, where of course often the moon is up in the sky in the daytime. It's either in front of the sun or it's behind the sun. And again, we've got this heliocentric model in which the explanation for moonlight is the moon reflecting sunlight. Well, again, this is something that might appear to fit as an explanation. And we can also make it fit as an explanation with a flat Earth or a concave Earth, if we like. Or even we could consider that we are in a lunar system rather than a solar system, and we could perceive or believe that the Earth is moving around the moon and the sun is doing something else. And we can again imagine or perceive or assume various different shapes or movements for the Earth, for the moon, or for the sun. There's a multitude of combinations of dimensions, shapes and movements that we can assume for each and every part of this system or realm that we see ourselves in. And this is what we have to be acutely aware of. We have to be aware that these observations can be interpreted in so many different ways, and this in itself tells us that no one way of perceiving it, no one model stands out as being the correct one, or anything that's ever been proven as any kind of fact, scientific fact. Yeah, nothing changes with the degrees of altitude that we might see the moon or the sun above the horizon right now. Nothing changes about where the horizon is at eye level. Yeah, nothing changes about the time that we see this come up in any given location. That is the model. The model is the predictive nature of the sun and the moon and their relationship with the earth. That's it. That's all any model is. How you then go and illustrate that depends on a whole wide range of assumptions that you have to make to be able to put together a complete model per se, and that can only ever be a model that is perceived or put on paper. And again, the mathematics doesn't change, the physics on this earth doesn't change from what we can observe and measure on any given or at any given location or time. Yeah, none of that changes. Nothing changes. The whole thing we have to understand here is that it is all open to interpretation, and it is totally open to assumption once you start trying to imagine where this earth is in relation to everything else, and where the stars and the moon are in relation to everything else, and where all that is in relation to whatever's beyond this, which none of us actually know. Nobody is an authority on that whatsoever. It has always been assumptions, and the only reason we have this widespread belief in a globe Earth is because that was pushed as a way to perceive what's going on, a way to keep time, a way of measuring time that is based on the Gregorian or solar calendar as opposed to a lunar calendar. So we end up with this consensus being put upon us, and it's been passed off as science. Again, the only science or scientific methodology that's being employed in any of these observations is the measurement of time and location or angles, which again can be interpreted in many different ways with whatever kind of geometry or trigonometry you wish to use. So then the mathematics doesn't become a fact of our physical reality. It just becomes a fact of the model of telling time by watching the sky. Yeah, it's really it's quite simple, and when we try to make it complicated, it gets overly complex and confusing, and we get distracted from the reality of the situation, and that is that we can interpret these observations in an infinite number of ways, and therefore we are lost and confused when we attempt to do that without having full knowledge of the origins, the causes and effects on a scale that is beyond anything that we can experience or know. These outside influences we can measure, and we can observe the influences in this frame of reference, if you like, this one we have, and we can perceive it from an external frame of reference. This is a very smart thing to be able to do, and it's what Einstein did. But really, this is nothing more than a leap of faith that we have somehow got it all worked out because of these thought experiments. Yeah? Alright, so just watching the moon from here, it's we've got the shadow there on the top off to the right. If I was to be watching this moon in Phuket near the equator, I would be looking at it like this. Whatever that actually means is a matter of interpretation, not something that can or should be dictated to us. Thank you very much.